Hey everybody, welcome to Math with ACE. We are focusing on statistics today, continuing our exploration into linear regression with bivariate data, where we have two variables and we're trying to see whether there's a relationship, what type of association there is. And one thing we want to consider is how strong the relationship is. We determine the strength of a relationship using the correlation coefficient, which is represented by the lowercase letter r. So Pearson's correlation coefficient is R. So whenever you see R, it's called the correlation coefficient. R squared is the coefficient of determination that comes later, but R describes for us the strength of the relationship. It can also tell us the direction of the relationship. So we can get two pieces of information from R. We can get the strength and we can get the direction. And how we calculate R, there is a formula. We're not going to use the formula, but I would love you to see that the calculation is found by taking the sum of every X value minus the average of the X data set and divide that by the standard deviation of the X values, and then multiply that by the same thing for Y. Get my little bar above here. And then we divide all of that by the sample size minus 1. And so if you have a small data set, it's easy for you to kind of do each X value minus the average, each Y value minus the average, maybe like 3 or 4 points. But when you get into calculating with large groups of data, it's very unrealistic to calculate the correlation coefficient by hand. So we allow technology to do that for us. And what happens is the computer or technology will figure out the line that best fits your data by looking at reducing the sum of squares for the residuals or the errors that happen. And we'll talk about that in the linear equation video, which is next. But once we get an output, we'll get an R value. And so we'll have an equation or we'll have the scatter plot with this line of best fit that is somewhere through the data. And the line of best fit is the one that has the squares minimized. And what I mean by that is each point gets a square. You draw a vertical line from the point to the prediction. And you have these squares that are created. And then you add up all the areas of the squares. And the one that has the least area of those squares summed together is the line of best fit. So if you draw a straight line through and you have all of these larger squares, you're trying to find your like Goldilocks. This line is too big, this line is too positive, too negative, whatever. You're trying to figure out which one is best. So the computer does that for us. And then what we can do is we can use this R value, this correlation coefficient, to tell us how strong our relationship is in the direction. So R is going to have either a positive or a negative. So for R that is positive, that means that there is a positive association between the X and the Y value. R that is negative means that there's a negative association between the X and the Y variables. And actually, I probably should positive R and negative R. So that way, whenever you have a negative sign in front, you know that that means that the line is negative. So going from left to right, it's dropping down. Higher X values are associated with lower Y values. The other thing that you can tell is based on the R value, you can see how strong your association is. So in a perfect world, if you have a line that has every single dot lives on that line, that means that every Y can be explained completely by the X values. That's a perfect world. The highest R value that you can get is a positive 1. In this situation, because it's a positive line. If I had a negative line, the highest or the strongest relationship is a -1. So R falls between -1 and +1. So a -1 means not that it's a bad thing. Negative just means that the linear regression equation is negative. That means that higher X values are associated with lower Y values. So the more miles you drive, the lower their car cost is. So this is a negative association. And in a situation with -1, particularly, that means that every point is on the linear regression line. The same can be true for +1. What that means for +1 is that every point is on the linear regression line, but there's a positive association. The higher X values are associated with higher Y values. Now, one thing to note is that when we are talking about R, this relates to two variables and linear regression. It is describing the strength of a linear relationship. We are not talking exponential, logarithmic, quadratic, any of those types of regression equations. We are talking specifically about linear regression. So when you have a value of 0, that does not mean there is not a relationship. It means there's not a linear relationship. Maybe it's a circle. Maybe it is purely quadratic. Maybe it is something that is completely different. Maybe it has some sort of a cubic function. However, it could be 0 because the relationship is not explained by a line. So 0 means that there is no linear relationship. Now then there's markers to tell us about the value of the correlation coefficient, to tell us how strong something is, of whether you have positives or negatives. Doesn't matter. Positive just means it's a positive relationship. Negative means it's a negative relationship. But the breakdowns or the barriers that we have will tell us, is this weak? Is it moderate? Is it strong? Some books will break up into moderately strong. I don't do that. It's either weak, moderate, or strong for us in our class. So our first breakdown is going to be at 0.3. So 0.3 or negative 0.3 to 0.5 or negative 0.5. And that breakdown, that's going to be weak. We would call that a weak linear relationship. And in a weak linear relationship, the dots are not going to be close to the line. They're going to be pretty scattered. Okay, the closer you get to that line, more of the points that are closer to the line, the stronger your relationship is. Our next breakdown is going to be at 0.5 to 0.8 and negative 0.8. We will call that moderate. That is a moderate linear relationship. And then lastly, from 0.8 to 1 or negative 0.8 to negative 1, that is strong. That's a strong linear relationship. So notice that R is between -1 to 1 inclusive, meaning it can be -1 and it can be 1, but only those values. Positives have a positive relationship, negatives have a negative relationship. But R does not have units. R is not about miles per hour, things like that. It is the strength of a linear relationship, and it is unit free. And it does not matter if you switch the X and the Y variables, the relationship is still the same. The R does not change when you change the explanatory and the response. There's no unit of measurement. It is standardized, and there's no distinction between the explanatory and the response. So those are some key features about R. When you are trying to describe the relationship, if you have a scatter plot where there are all sorts of dots that whenever you maybe put a line through it, that doesn't seems like they're kind of far away, that is a weaker relationship. But again, when you look at this one where all the dots are on the line, that's a stronger relationship. So when you see a lot of dots spread out, that's going to be weaker. And the closer they are to whatever your line is going to be is a stronger relationship. So let's look at this scatter plot that we had for the Ford F-150 example. If we were to draw, this is by eye, which is not going to be the best, but let's say we draw our linear regression equation here, I can see those points are fairly close. These, maybe a little bit of an issue. If I could get rid of those lower miles driven, price low cars, maybe that other one, the rest of these values seem pretty close to the line. So I would say this is, it's not weak, but I don't think it's super strong. If we go into Staplet and you go to your, let's see, two quantitative variables, there is a button once you enter your data that says calculate correlation. And once you click calculate correlation, you are then presented with the correlation coefficient. So this correlation for the example we have here is negative 0.6782. What does the negative mean? It means the line of best fit is negative. What does the 0.67 mean? It means that it falls here with the moderate. So I would say that there is a moderate negative linear relationship between miles driven and price of Ford F-150s. Okay, so whenever you're asked to describe the relationship between the two variables, you look at R to tell you what's the sign, what's the strength, and then you look at the graph to tell you whether it's linear or not. Thanks for watching. Stand by for our next video where we talk about the linear regression equation.